and welcome. The problem in this video requires us to find the voltage drop across the 40 ohm resistor and the power dissipated in it using superposition. First thing we want to do is that we want to turn off this current source while leaving this voltage source on and find the voltage drop due to this voltage source. Turning off a current source results in an open circuit. Then the circuit will look something like this. The circuit will look something like this with the current source absent. What we want to do next is we want to find the voltage drop due to this power source, and for that we can simply use nodal analysis. If we do use nodal analysis, we only have one essential node in the circuit. The other would be the reference node. So we have V1 minus 100 divided by 20. So V1 minus 100 divided by 20 plus V1 divided by 40 plus V1 divided by 10 plus 2.5 all equals 0. That is a KCL equation. Simplifying further, we would have it that 2V1 minus 200 plus V1 plus 3.2 V1 equals 0. Then we'd have that 6.2 V1 equals 200 and V1 equals 32.26 volts. This is the voltage across the 40 ohm resistor due to this power source. Now we go ahead to consider the action of this current source alone by turning off this voltage source, and we are left with a short circuit when we turn it on. Turning on only the current source would leave us with a circuit that looks like this, and we can find the voltage drop across the 40 ohm resistor. We can simply use nodal analysis. We have three essential nodes, 1, 2, and 3. And then if we make this a reference node, this would be node 1 and this would be node 2. Okay, with that we can write equations for each node. At this node we would have node 1. We have V1 over 20, okay, plus V1 over 40 plus V1 minus V2 over 10 plus V1 minus V2 over 10. We can then multiply through by 40. If we multiply through by 40, we would have 2 V1 plus V1 plus 4 V1 minus 4 V2 all equals 0. We can then simplify this and we can write it as 7 V1 minus 4 V2 all equal 0. We can call this our first equation. We can then proceed to this next node and write a KCL equation at the node 2. At node 2, the equation would be v2 minus v1 divided by 10. So let's say n2 v2 minus v1 divided by 10. We would also have v2 divided by 2.5 plus v2 divided by 2.5. Then we will have minus 6 equals 0. We can multiply through by 10, and that would give us v2 minus v1 plus 4v2 equals 60. We can call that our second equation. We can then solve it simultaneously with this. Okay, we can simplify further, and we would have 5v2 minus v1 equals 60. We can solve it simultaneously with this equation, and we'll get a value for v1 and v2. The value of v1 in this case would be 7.74 volts, and v2 would be 13.54 volts. So we expect the voltage drop across the 40 ohm resistor to be 7.74 volts. We can add it up with this voltage from due to the 100 volts power source, and we would have let's call the voltage across the 40 ohm resistor V40, and then the total voltage would be 32.26 plus 7.74, and that would be 40 volts. And it will be in this direction, so we would have positive and negative. And then the next thing we want to do is that we want to compute the power dissipated. So P is equals to V squared over R. So we can say 40 times 40 divided by 40, all equals to 40 watts. Now, one thing I want to call your attention to is the fact that you cannot superimpose power the way you superimpose voltage and current, because power is not a linear property. So if you individually calculated this power, the power due to this voltage and the power due to this voltage, and you try to sum them up afterwards, you would get a wrong answer. That will be all for today. Thank you for watching. Bye.